Okay, thank you, Klaus, and good afternoon. Pleasure to be here, and I'll get right with it because there's a short time for our presentations. So, let's see. The first point I want to make is that the information that Steve Pilkerton and I have put together to share with you is just a highlight of some operational issues, but it's really based on a lot of time spent in research and a lot of experience. It really it spans over a 35-year period, and the information comes from a lot of harvesting equipment and system studies that we've done in density management applications with small wood and thinnings and different kinds of treatments. Extending the research into our Oregon State University student logging training program, where we have a small yarder, skidder, and things of that nature, and we're actually operational training and including that kind of education for our students. Other research projects that I'm sure you've talked about yesterday and today are of course, the Siuslaw National Forest Young Stand Study, the Willamette National Forest Young Stand Study, and then also the more recent second entry into the Willamette, or into the Siuslaw National Forest Study, also known as the STUDS project. So what we'll cover today, the three things that I picked out to highlight with you that I thought would be relevant for our audience is harvest planning and layout, alternative harvesting systems, and residual stand damage. I think are pretty relevant topics that we're all interested in. And then Steve Pilkerton is going to come up and conclude with some of his observations following the second density management entry on the STUDS project. Okay, so the harvest planning and layout, and what I've chosen to use here for an example to get my points across are is the Willamette Young Stand Study, 4 replications of 3 silvicultural treatments, heavy, light, and light thin with gaps, and I'm assuming that you've covered more detail on the stands and the treatments in other presentations, so I'm not going to spend time on that. But the logging systems were really pretty comprehensive. There were 4 different thinning sales in the Willamette Young Stand Study. Involved a range of chainsaw felling and tractor skidding, cut-to-length harvester and forwarder operations, and chainsaw felling and skyline yarding. And remember, I'm talking about harvest planning and layout, and we did a kind of an interesting thing with this project. We actually collected the time it took for the Forest Service districts to do the sale preparation, and then we also followed with the logger and the times that were spent with them in laying out the units. And that's a big factor, I think, that our following speaker is going to talk about, and you probably recognize, well, there's more time involved in laying out some of these treatments on the ground and administering them. Well, we had some data on this Willamette Young Stand Study that documented that, and I just want to share that briefly with you. So the take-home messages that I would say from this study are one, the harvest planning and layout time and cost had no relationship to silvicultural treatments in this study. And I think that's pretty true with other operations too. So when we look to try to see if light thinning or light thinning with gaps or heavy thinning took more time to lay out because of the treatment or the silvicultural treatment, we just couldn't find any connections there. I think you would probably appreciate the next one, and we weren't able to get statistical results, but we had a lot of observations from our studies about the importance of the site characteristics affecting planning and layout costs. Things like topography, understory vegetation, how much RMA areas are located in the unit, how much unit boundary requires marking, the experience of the crew. Those were all factors that were more important really in affecting the time in laying out these units than just the difference between the actual silvicultural treatment. Now hopefully you've been thinking about that last bottom bit of the slide there, wondering what goes in there, and this is the rest of the story on the logging layout. The contractor time and cost were definitely, however, were related to the type of the logging system. And our data showed that it was faster and cheaper, laying out cut-to-length operations. Then the next more expensive was a tractor, followed by the most expensive skyline operations. I don't have time to elaborate on that, but I put these example diagrams in there just to give you a feel that with cut-to-length operations, things are more uniform, consistent, often relying on operators laying out or just moving their equipment along the ground where they need to operate. Things get more complicated with designated skid trails in variable terrain, and the most complex layout would be skyline logging on steeper ground where you're trying to line up corridors, intermediate sports, tail trees, and so forth. The other last point I'll make on the planning part is, well, what we see on the left is a graph of the Willamette-Youngstown study, the Forest Service planning and layout components for all of our sales, all the 4 sales we put in this pie graph. And so as you glance at that, you can see the bigger ones, the bigger parts of the pie, marking leaf trees and patch perimeters and other parts in there. We could spend a lot of time talking on that I don't have, but so the point that I want to emphasize here is the logging part. Logging design and other. Other was largely running ground profiles, marking landings, the kind of things that you do in harvest planning. That only consumed about 10%, 6.7 plus 3%, about 10% of the total time involved in planning and laying out these sales. So what is happening is more of the time is being required for the contractor. The contractor has a much more important role in laying out spur roads, landings, and laying out extraction routes, skyline roads, and so forth. And so I think a real key, what I've observed over the years in working with the density management prescriptions, is really expecting and getting a good contractor involved in doing a lot of the on-the-ground layout that used to be done more in the past with our timber sale programs, but we've rapidly changed to different modes of operation. Second point, alternative harvesting systems. Well, we know that there's a lot of different choices with conventional tractors and skidders, cut-to-length systems, small skyline systems, and even a helicopter yarding. And our job is often to match the appropriate system to the objectives for the site and the site-specific characteristics. Well, question might be, well, how do the silvicultural methods or the different treatments, whether they're light thinning or heavy thinning or gaps or whatever, how do they affect the differences in harvesting cost? And here I have a graph from our Siuslaw National Forest Youngstown study. And just to interpret it real quickly, we have 2 sites, Yachats and Hebo. We have the blue felling, the cable yarding above that, and then the move-in and move-out cost, which actually is getting more significant these days with a lot of seasonal restrictions and contractors moving equipment in and out to complete their operations. Well, what we have here are residual trees per acre in a 33-year-old stand, average DBH 11 inches, and bringing about 300 trees per acre down to 100 trees per acre, 60 or 30. So 30 would be a heavy thinning, and as you might expect, the cost, it's a smaller bar there, the costs are lower and they go up as we're having a lighter thinning. However, those differences are not real great. Between the 30 and 60, that's a 6% increase. Between the 30 and the 100 is a 12% increase. And so I guess I've kind of formed a conclusion in looking at a lot of these different silvicultural methods that there aren't, if we plan it and get the contractor involved, there's not a real big difference in the implementation phase if it's planned and laid out appropriately. And we've seen that in other study sites as well. What is more important, again, we could not find any relationships with silvicultural treatment and the logging methods, but what we found more difference was with the operational differences with the contractors. And there was a wide range of innovations that contractors had with different kinds of skyline carriages, with bunching wood in skyline operations with some of our mechanized equipment, bunching wood for helicopter operations to make them more productive, utilizing machines like the yellow machine there, which has a combination loading grapple that can be moved out of the way, and also using as a harvester processor head. Those sort of innovations really had more of effect on the harvesting costs than just the silvicultural treatment. Range of harvesting productivity and cost, just to kind of give you some numbers, as you would certainly expect, from low to high. We'd have this range from horses to helicopters. Daily range of production between about 1 to 10 truckloads a day. So 10 would be in the helicopter side, and 1 would be down in the small crawler tractors or horses. Same thing with volume and daily costs, quite a range there. And finally, just some numbers on dollars per 1,000 board feet. So the point there is that, you know, with log values today that are $400 to $500 per 1,000, it's challenging to do these operations economically. And I think that it's very important to get the silvicultural treatments laid out on the ground so that they can be economically harvested. And we have to accomplish, of course, the objectives that you all have been talking about during the conference, but a lot of things are just not going to happen on the ground unless there's efficiency in the harvesting operation to be able to do that economically. The last point before I turn it over to Steve to conclude is residual stand damage, and we've done a lot of studies in that area, and I've just chosen to summarize work by one of my previous PhD students, Dr. Han-Sup Han, with 4 harvesting system studies, including helicopter, range of different stand density treatments. And he found that in these studies, scarring was the most common damage compared to crown breakage and root damage. Damage levels, really interesting. This is more of a subjective thing than much science behind it. How much percent of the residual stand damage is significant? Well, it depends on the definition of what a significant damage is to a tree. And we found anything from 24 square inches up to 144 square inches that were used in various places around the western region of North America for identifying significant damage. Well, obviously, depending on your definition, that really affects the percent of damage that you really have. Scarring by ground-based systems were more severe than skyline and helicopter systems. That means that they were closer to the ground, which is a bigger issue. There were more gouging and more damage to the roots with ground-based systems. The harvester caused more wounding of trees than forwarders. However, the forwarder had more significant damage with more gouging of the trees. And this is really kind of interesting in assessing the damage where it's located. It's concentrated within 15 feet of the skid trails or the skyline corridors is where most of the damage occurs. And my last slide before Steve comes down and starts. Steve, are you here? Yes, sir. Okay, so good. I thought I saw you back there. Because we want to keep moving right along. But you know, I think more importantly with stand damage, I am totally convinced that we have the experience and we know techniques to minimize stand damage in our operations. And this is just an example for skyline systems based on our experiences identifying felling patterns, skyline corridor layout, again something the contractor does, the skyline carriage and the crew experience, skyline corridor spacing, using intermediate supports to reduce the lateral excursion of the skyline, using rub trees along the corridors, even tree pads where they're needed, and extra care and slowing down a bit during the sap flow. All things that we can do. So I'm going to stop there. Steve's got 5 minutes to wrap things up on indicate little observations on the second entry with thinnings.